China.
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 In a quiet laboratory in Shanghai, Chinese scientists have just shattered everything we thought we knew about computing. While the world was focused on traditional silicon chips and semiconductor wars, they were building something entirely different. A computer that processes information using light itself. The implications are staggering, and they're about to reshape the global balance of technological power. Meet Meteor 1, a breakthrough that makes even the most advanced American processors look like ancient technology. This isn't just another incremental improvement in computing, it's a fundamental reimagining of what's possible. The numbers alone tell a shocking story. 2,560 tera-operations per second, nearly double the processing power of Nvidia's flagship RTX 4090, currently considered the gold standard in AI computing. Inside this thumbnail-sized chip, over 100 different wavelengths of light operate simultaneously, each carrying its own independent stream of data. Imagine having 100 separate computers working in perfect parallel, without generating heat, without facing electrical resistance, and without interfering with each other. Traditional silicon chips, no matter how advanced, simply can't match this level of sophistication. But the true genius of Meteor 1 lies in its efficiency. While Nvidia's best chips struggle to achieve 10 tera-operations per second per watt, Meteor 1 delivers 160. In a world where data centers consume as much electricity as entire nations, this isn't just an improvement, it's a revolution. The environmental implications alone are enough to make tech executives lose sleep. The timing couldn't be more dramatic. For the past 3 years, Washington has been methodically tightening restrictions on China's access to advanced semiconductors, export bans on high-end chips, restrictions on manufacturing equipment, diplomatic pressure on allies to fall in line. The strategy was clear: maintain American technological dominance by controlling the supply chain. But while U.S. policymakers were building walls, Chinese scientists were building bridges to the future. The Shanghai Institute of Optics and Fine Mechanics, working alongside Singapore's Nanyang Technological University, has achieved something Silicon Valley claimed was years away from reality. At the heart of Meteor 1 sits a remarkable piece of technology called a soliton microcomb, a device that generates over 100 coherent light channels from a single source. Where previous attempts at optical computing required entire rooms filled with lasers and cooling equipment, Meteor 1 integrates everything onto a single chip. The precision is mind-boggling, more than 200 stable wavelengths across 80 nanometers of spectrum, each one precisely controlled and modulated. The implications ripple far beyond the laboratory. In artificial intelligence, where training large language models can cost millions in electricity alone, Meteor 1's combination of speed and efficiency could slash both time and cost by orders of magnitude. For autonomous vehicles processing enormous amounts of sensor data, financial systems requiring split-second analysis, or military systems demanding immediate threat assessment, the advantages are game-changing. But perhaps most concerning for Western officials is how this breakthrough sidesteps every restriction and sanction carefully put in place. Unlike traditional semiconductor manufacturing, which requires billion-dollar fabrication facilities and equipment controlled by a handful of Western companies, Meteor 1's optical components can be produced using modified versions of existing laser manufacturing technology. What's particularly striking is that this isn't some theoretical laboratory curiosity. The team has already demonstrated Meteor 1 successfully executing over 100 simultaneous tasks in benchmark tests, all running at a 50 GHz optical clock speed. These aren't simulations or projections. These are real-world results from a working chip. The research team's recently published paper in the journal eLight reads like a declaration of technological independence. But behind the scientific achievement lies an even more remarkable story. Intelligence sources now reveal that Meteor 1 represents the tip of a massive technological iceberg. the product of a coordinated effort involving 7 major Chinese universities, 3 state-owned technology conglomerates, and direct funding from the People's Liberation Army's Strategic Support Force. The scale of investment is staggering, over $2 billion spread across 8 years of intensive research. This wasn't just another research project, it was a carefully orchestrated campaign to fundamentally alter the global technological landscape. But the revelation of Meteor 1's capabilities is just the beginning. Intelligence reports now indicate that China's optical computing breakthrough has triggered a seismic shift in global tech investments. Major corporations from Singapore to Switzerland are redirecting billions in research funding toward photonic computing, recognizing that the Silicon era may be drawing to a close faster than anyone anticipated. The implications for artificial intelligence are particularly striking. Current AI models like GPT-4 require massive data centers consuming as much electricity as small cities. With Meteor 1's architecture, similar models could be trained in a fraction of the time, using just 1/10 of the power. This isn't just an efficiency gain, it's a fundamental redrawing of what's possible in machine learning. Perhaps most concerning for Western military planners is the chip's potential in autonomous systems. A senior Defense Department analyst, speaking on condition of anonymity, reveals, Meteor 1's ability to process sensor data from multiple sources simultaneously, with near-zero latency, could give Chinese autonomous weapons systems a decisive edge. We're talking about drones and missiles that can make complex decisions in microseconds. The environmental implications are equally profound. Data centers currently consume about 1% of global electricity, a figure projected to rise dramatically with AI's expansion. Meteor 1's energy efficiency could slash that footprint dramatically. This isn't just about computing power, explains Dr. Elena Rodriguez, a climate tech specialist. It's about making advanced AI sustainable at a planetary scale. But the most immediate impact may be economic. Market analysts estimate that if China can scale production of Meteor 1 chips by late 2026 as planned, it could capture up to 30% of the global high-performance computing market within 5 years. That's hundreds of billions in revenue currently flowing to American companies potentially redirected to Chinese manufacturers. The chip's architecture also presents unique challenges for cybersecurity. Traditional encryption methods assume certain computational limits, warns Dr. James Chen, a cryptography expert. When you can process 100 parallel streams of data simultaneously, those assumptions break down. We'll need entirely new security protocols. European nations find themselves in a particularly difficult position. Many have invested heavily in traditional semiconductor facilities, but Meteor 1's emergence suggests those investments might soon be obsolete. It's like building the world's best horse-drawn carriage just as the automobile is invented, notes one EU technology commissioner. The research team's latest tests reveal capabilities even beyond initial reports. Running complex climate models that typically take weeks on supercomputers, Meteor 1 completed similar calculations in hours. The chip maintained stable operation at 50 GHz optical clock speeds, a rate that would melt conventional processors instantly. Beijing's strategy becomes clearer in hindsight. While Western sanctions focused on controlling traditional chip manufacturing, China invested heavily in alternative computing paradigms. The $2 billion invested in optical computing research now looks like a bargain compared to the hundreds of billions spent on conventional semiconductor fabs. The race to catch up is already beginning. Intel has announced a $5 billion investment in photonic computing research. IBM is repositioning its quantum computing team to explore hybrid optical quantum systems. But they're starting years behind, and China's head start in manufacturing infrastructure could prove decisive. Market responses have been dramatic. Share prices of traditional semiconductor manufacturers have plunged as investors digest the implications. Meanwhile, Chinese tech companies involved in optical computing research have seen their valuations soar. The market is betting that the future belongs to photons, not electrons. Military planners are particularly concerned about the timeline. We're not talking about a theoretical advantage years away, notes one Pentagon official. Meteor 1 is real, it works, and it's being integrated into systems now. Every assumption about technological superiority needs to be reassessed. What's particularly striking is how the breakthrough emerged from collaboration between civilian universities and military research. The People's Liberation Army's Strategic Support Force provided not just funding but strategic guidance, identifying optical computing as a critical path to technological independence nearly a decade ago. As the implications continue to ripple outward, one thing becomes clear. The global tech landscape is being rewritten faster than anyone expected. In the quiet laboratories of Shanghai, Chinese scientists haven't just built a faster computer. They've fundamentally changed the rules of the game.
China.
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 China. China. China.
In August 2025, Thailand's cabinet made a decision that sent shockwaves through the global defense industry. After 8 years of delays, diplomatic standoffs, and technical hurdles, they approved the use of untested Chinese engines in a billion-dollar submarine deal that Germany had tried desperately to kill. This wasn't just about submarines. It was about the moment China proved it could outmaneuver Western sanctions and emerge stronger than ever. The story begins in 2017, when Thailand's Royal Navy faced a critical problem. Their aging fleet needed modern submarines to patrol the strategic waters of Southeast Asia, where tensions with neighboring powers were escalating. After an international bidding war involving South Korea, France, and Germany, China's shipbuilding giant CSOC won the contract with their S-26T submarine, a deal worth 13.5 billion baht, roughly $417 million for the first vessel. And exciting news, we're also working on a second channel covering China-US politics, Huawei chips, and everything about China's technology future. We've placed the link in the description below, so make sure to check it out and subscribe. But here's where it gets interesting. Thailand didn't just want any submarine. They specifically demanded German-made MTU-396 diesel engines, the gold standard for submarine propulsion. These engines were legendary in naval circles, whisper quiet, incredibly reliable, and used in submarines from Brazil to South Korea. The MTU-396 wasn't just an engine, it was the beating heart that would make Thailand's submarine nearly undetectable in the depths of the South China Sea. China agreed to the terms without hesitation. Construction began at their state-of-the-art shipyard, with engineers working around the clock to build what would become one of the most advanced conventional submarines in Southeast Asia. The S-26T featured air-independent propulsion, digital sonar systems capable of tracking multiple targets simultaneously, and noise levels so low, between 80 and 90 decibels, that it could blend seamlessly with ocean background noise. For comparison, that's quieter than many nuclear submarines costing 5 times as much. Everything was proceeding smoothly until 2021, when the project hit an unexpected wall. Germany, citing the European Union's arms embargo on China, a policy dating back to the 1989 Tiananmen Square crackdown, suddenly refused to export the MTU-396 engines. The embargo, designed to prevent military technology transfers to China, had been largely overlooked for decades. But now, with China's military rise causing anxiety in Western capitals, Germany decided to enforce it strictly. The timing couldn't have been worse. The submarine was already 64% complete, with millions of dollars invested in specialized infrastructure. Thailand had spent 8 billion baht on submarine docks, training facilities, and personnel development. The Royal Thai Navy had sent officers to China for months of training on systems that might never be delivered. As one defense analyst in Bangkok explained at the time, this wasn't just about one submarine. Thailand was looking at this as the foundation for rebuilding their entire underwater warfare capability. Suddenly, that entire vision was in jeopardy because of a European political decision made thousands of miles away. China found itself in an impossible position. They had a nearly completed submarine sitting in their shipyard, but without the German engines, it was essentially a very expensive piece of metal. The Chinese shipbuilders proposed an alternative, their domestically produced CHD-620 engines. But there was a problem that made everyone nervous. These engines had never been used in any operational submarine, not even in China's own navy. Thailand's military leadership was understandably skeptical. Admiral Somchai Jirathawat, speaking to defense officials in 2022, reportedly said, "We're not interested in being test subjects for unproven technology. Our sailors' lives depend on these systems working flawlessly under pressure." The Royal Thai Navy had built their entire submarine program around proven German technology, and switching to an untested Chinese alternative felt like an enormous gamble. The standoff dragged on for months. Thailand explored every possible workaround, even proposing to have the submarines delivered to Thailand where German engines could be installed locally. This would technically avoid Germany's export restrictions to China, while still giving Thailand the engines they wanted. But Germany rejected this proposal too, making it clear they wanted to prevent any German technology from ending up in Chinese-built military equipment, regardless of the final destination. By October 2023, the situation had become untenable. Defense Minister Sutin Klungsang announced that Thailand was canceling the submarine contract entirely, considering instead the purchase of a Chinese-built frigate. The decision sent ripples through the defense industry. China stood to lose not just a major contract, but credibility as a reliable defense partner. If they couldn't deliver on their promises to Thailand, other potential customers might think twice about Chinese military equipment. But China wasn't ready to give up. In May 2024, a high-level delegation of Chinese military and shipbuilding representatives arrived in Bangkok for what were described as intensive discussions. What happened in those closed-door meetings remains classified, but the results spoke for themselves. Within weeks, Thailand reversed its cancellation decision and agreed to move forward with the Chinese engines. The breakthrough came from an unexpected source, Pakistan. When Pakistan had ordered 8 Chinese S-20P submarines in a $5 billion deal, they faced the same German engine problem. But unlike Thailand, Pakistan had immediately accepted the Chinese CHD-620 engines, trusting in China's technological capabilities. By 2024, Pakistan's submarines were operational, and their performance data provided the proof Thailand needed. Thai naval engineers spent months in Pakistan, conducting rigorous evaluations of the CHD-620 engines in real-world conditions. They ran 200-hour continuous operation tests, subjected the engines to extreme stress scenarios, and even obtained certification from Lloyd's Register, one of the world's most respected maritime classification societies. The results were surprising. The Chinese engines not only matched the German MTU-396 in power and reliability, but actually exceeded them in fuel efficiency and environmental performance. As a senior Thai naval engineer who participated in the testing later explained, "We went in expecting to find compromises and limitations. Instead, we found engines that had been specifically optimized for submarine operations in ways the German engines hadn't been." The Chinese had clearly learned from decades of studying Western technology and had improved upon it. The final cabinet approval in August 2025 marked more than just the resolution of a submarine contract. It represented a fundamental shift in the global defense landscape. Germany's attempt to use export controls as a weapon against China's military industry had not only failed, but had actually accelerated China's development of indigenous alternatives. The CHD-620 engine, born out of necessity due to Western sanctions, was now positioned to compete directly with established European technology in international markets. For Thailand, the decision meant accepting a 3-year delay in delivery, with the submarine now expected in 2027 instead of 2023. But it also meant proceeding with a contract that would ultimately include 3 submarines for over $1 billion. Making Thailand one of China's largest submarine customers. The Royal Thai Navy would finally get the underwater capability they had been seeking for nearly a decade. The implications extended far beyond Thailand's borders. Other Southeast Asian nations watching this drama unfold saw that China could deliver on its promises even when faced with Western interference. Malaysia, Indonesia, and the Philippines all had their own submarine programs under consideration, and China's success in overcoming the German embargo sent a clear message about reliability and technological independence. The real shockwaves from Thailand's decision reached far beyond Bangkok's defense ministry. Within weeks of the August 2025 approval, intelligence reports began circulating in Pentagon briefing rooms about China's accelerated submarine production capabilities. What Western analysts discovered was deeply unsettling. The CHD-620 engine that Thailand had finally accepted wasn't just a replacement for German technology. It represented a quantum leap in Chinese military engineering that nobody saw coming. By late 2025, satellite imagery revealed construction at China's Jiangnan shipyard had expanded by 40%, with dedicated production lines specifically for the CHD-620 engine system. The facility wasn't just building submarines for Thailand anymore, they were preparing for mass production. Defense intelligence estimates suggested China could now produce 12 submarines annually using entirely domestic components, completely bypassing any future Western export restrictions. The strategic implications hit Washington like a thunderbolt. For decades, American policy had relied on choke points in global supply chains to limit China's military capabilities. If China needed German engines, American semiconductors, or European navigation systems, the West could theoretically control the flow of critical technologies. The Thai submarine crisis had revealed a fundamental flaw in this strategy. Sanctions weren't slowing China down, they were forcing rapid innovation that made China stronger and more self-reliant. A former Pentagon strategist, speaking privately to defense contractors in November 2025, warned colleagues that, "We've essentially handed China a masterclass in supply chain independence. Every embargo we impose forces them to develop indigenous alternatives that ultimately compete with our own industries." The Thailand submarine deal had become a case study in unintended consequences. Meanwhile, across the South China Sea, Malaysia's defense ministry quietly initiated discussions with Chinese shipbuilders about their own submarine requirements. The Malaysian Navy had been evaluating European options for years, but Thailand's experience suggested that Chinese technology could deliver equivalent capability at significantly lower cost. More importantly, Chinese suppliers wouldn't weaponize export licenses for political leverage. The ripple effects accelerated through 2026. Indonesia announced a preliminary agreement to purchase 4 Chinese submarines equipped with the now-proven CHD-620 engines. Brazil, despite its traditional ties to European suppliers, opened negotiations for technology transfer agreements that would allow local production of Chinese submarine components. The Thai submarine that had started as a single-vessel contract was morphing into China's entry ticket to the global submarine market. Behind the scenes, German defense giant MTU was scrambling to understand how they had lost control of a market they had dominated for 30 years. Internal company assessments obtained by industry insiders revealed the stark mathematics of their miscalculation. By enforcing the arms embargo against China, MTU had forfeited not just the immediate Thai contract worth 50 million euros, but potential future contracts worth over 2 billion euros as China's submarine exports expanded globally. The German government found itself facing uncomfortable questions from domestic defense industries. BMW, which owned MTU, reported to shareholders that Chinese competition in marine engines had intensified dramatically since 2024. The company that had once enjoyed a virtual monopoly in high-performance submarine engines now faced a competitor that could offer equivalent technology without the political complications of European export controls. By mid-2026, the geopolitical landscape had shifted decisively. China's State Council Information Office published detailed performance data for the CHD-620 engine, openly marketing it to international customers. The specifications were impressive: 15% better fuel efficiency than comparable German engines, 40,000-hour operational lifespan, and noise levels below 85 decibels. Most significantly, the Chinese engines came with a guarantee: No export restrictions, no political conditions, and no threat of supply interruption due to diplomatic disagreements. Thailand's submarine finally entered sea trials in early 2027, nearly a decade after the original contract signing. The Royal Thai Navy conducted exhaustive testing in the Gulf of Thailand, putting the Chinese engines through scenarios that simulated everything from emergency surface operations to extended underwater endurance runs. The results exceeded expectations across every metric. Admiral Prachachart Sirisawat, Thailand's submarine program director, reported to Parliament that the vessel performs at levels comparable to any submarine in our regional waters, regardless of country of origin. The success of Thailand's submarine created a domino effect across Southeast Asia. Singapore's defense ministry, traditionally aligned with Western suppliers, began evaluating Chinese naval technologies for the first time. Vietnam, despite its complex relationship with Beijing, initiated quiet discussions about submarine modernization programs that could potentially include Chinese components. The region that had once been viewed as a natural market for American and European defense exports was rapidly diversifying its supplier base.
China. 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 China.
China has indeed resurfaced a 158-kilometer stretch of the Beijing-Hong Kong-Macau Expressway using only AI-powered drones and autonomous robots. This project involved drones surveying the highway to identify repair needs and robots executing the resurfacing work, all without human involvement on site.
At 5:47 a.m. on a foggy morning outside Beijing, 10 massive machines rolled onto China's most important highway without a single human operator behind their controls. What happened next would fundamentally change how the world thinks about construction forever. These weren't ordinary construction vehicles. Each one was powered by artificial intelligence systems so advanced they could make thousands of critical decisions every second while laying down perfect asphalt at highway speeds. In just weeks, this robotic army had accomplished something no country had ever attempted, building 157 kilometers of highway using almost entirely autonomous machines. The location wasn't chosen by accident. The Beijing-Hong Kong-Macau Expressway serves as China's economic lifeline, connecting the political powerhouse of the north to the manufacturing centers of the south. This is the same stretch of road that created international headlines in 2015 when it became the site of the worst traffic jam in human history. And exciting news, we're also working on a second channel covering China-US politics, Huawei chips, and everything about China's technology future. During National Day celebrations, over 750 million people were traveling when a bottleneck at a toll station turned 50 lanes into just 20. Cars sat motionless for hours, stretching back for miles in what media dubbed Carmageddon. That disaster taught Chinese leadership a crucial lesson. Their infrastructure needed to be smarter, faster, and more efficient than anything the world had seen before. The solution came in the form of the most sophisticated construction project ever attempted. At the heart of this robotic revolution was the SAP-200C10, a machine so advanced it defied everything engineers thought they knew about highway construction. This mechanical giant could lay down 4 lanes of highway simultaneously. Its 19.25-meter wide screed stretching across the entire width of the expressway. Unlike traditional pavers that require multiple passes and human operators constantly adjusting settings, this autonomous beast spread hot asphalt with surgical precision that human workers could never match. But the real breakthrough wasn't just one machine working alone. The entire operation functioned as a coordinated robotic ecosystem. Behind the massive paver came 6 13-ton double drum rollers that pressed the hot asphalt into place with mathematical precision. Then 3 enormous 30-ton rubber-wheeled rollers provided the final compaction, ensuring every square meter met exact specifications. Here's where the technology becomes truly remarkable. These machines weren't simply following pre-programmed routes like factory robots. They were making complex decisions in real time, analyzing road conditions, adjusting pressure and speed, and coordinating with each other through China's Beidou satellite system with centimeter-level accuracy. Think about that precision for a moment. These machines could place asphalt with the accuracy of a surgeon's scalpel while moving at construction speeds across uneven terrain. The artificial intelligence controlling each machine was constantly processing data from dozens of sensors.